Okay, here we have a problem, and this is the way we're going to be solving these types of problems here. Okay, um, so how do we work with these problems here? We're going to look at them very analytically, and then we solve them. See what we are being asked from the problem. It says Joshua noticed that compressing a gas is done by reducing its volume and raising its temperature. This is the whole concept. So this is what he has observed. Okay, so this is the whole idea of this problem. Joshua noticed that compressing a gas by reducing its volume and raising its temperature. What happens? Okay, Joshua has a pump that can hold 70 centimeter cube of air when pulling on the lever of the piston. Air around that day was 18 degrees Celsius, or in other words, that is room temperature, or the temperature around the neighborhood, and 1 atmospheric pressure. Calculate the pressure of the air that is forced into the tube if compression reduces its volume to 25 centimeter cube and raising its temperature to 58 degrees Celsius. Now, in this type of problems, what you need to do is this. If you don't remember which law to use, that's not a problem. What you need to do is as follows. Look at it in a way as to say that you want to work it out, and say, how you can say it, you can apply the combined laws of gas and then see what remains constant. Notice it says his pump can hold 70 centimeter cubes of air when pulling on the lever of the piston. Air around that day was 18 degrees Celsius. So let's set up what we have been given. Alright, so these are the information given to you guys. So our solution is as follows. Volume of air is 70 centimeter cube. The temperature of the day was 18 degrees Celsius. That's temperature 1, value 1, and the pressure was 180 atmospheric pressure. Okay, now that is at first. Calculate the pressure of the air that is forced. Now remember, he forces the air out, so that means that there's some force, something is being applied. If compression reduces its volume to 25 centimeter cube, okay, and raising its temperature to 58 degrees Celsius. So volume 2 now has been forced, let's see, forced into a tube if the compression reduces its volume to 25 centimeter cube. This is its new value, and raising its temperature 2 now is 58 degrees Celsius. So what is the pressure 1? Okay, calculate the pressure, it tells you here. So this is what we are looking for. Now for you to work with this temperature here need to be converted to Kelvin. That's a key factor here. So just a while ago we were learning how to convert Celsius to Kelvin. So for Celsius to Kelvin, we simply took the Kelvin value, and we from Kelvin to Celsius we took the Kelvin and subtract 273. But if we want to go from Celsius now to Kelvin, we'll just take this value and add it on to 273. So for this piece here, we can put 18 plus 273, and that gives us now 291 Kelvin. Okay, so that's what we get there, because that is what we do. Remember steps here. Okay, Celsius to Kelvin, so that's what we do. So we get that to Kelvin, and we must do that same thing on the other side. We take 58 plus 273 equals 11 and 12, 13 and 3 Kelvin. So we have temperature, we have volume, and so forth. That is okay. So now we recall the equation now, and we take P1 V1 over temperature 1 equals P2 V2 over temperature 2. What we want is pressure 2, so we apply algebra here, and we end up with P2 is equals to P1 V1 temperature 2 over T1 V2. There are some steps here that you need to know by now. especially the ones who are doing CXC physics. You need to be able to follow this up. All right, no exceptions. Now, since you have that equation set up and that's what you want, then you just simply to substitute into the equation. So we do that. So we take that pressure 2 now is equals to pressure 1 ATP, or we put just simply 1 times volume. What's the volume? Volume 1 is 70 centimeter cube. Temperature 2 now is 331 Kelvin over temperature 1, which is 291 Kelvin, times volume 2, which is 25. Since we know that we are looking for pressure, we don't need to worry about the units at this point, because all of those will be solved or will be canceling out for us to end up with the unit that we are so looking for. Okay, so since we have reached that point now, they just simply to evaluate. I'm not expecting you guys to go and multiply this up and multiply the top piece only by itself and then divide by the bottom piece. So you're going to say with your calculator 1 times 70 times 331 divided by open bracket 291 times, but remember, since we use open bracket, okay, we end up with pressure of 3.18848797251. That's the kind of answer that you end up with, pressure 2. Now, because we are working with lone whole numbers, my advice is to round it up to 1 decimal point. So this becomes then 3.2 atmospheric pressure, and you put here 1 dp. You need to state how many decimal points you are rounding off the problem to. Okay, here we have a next type of question. A special container well sealed. What does that mean? A fixed container, a container that is locked, a container that cannot be opened, a container that does not have a leak, once closed or once sealed, contains a gas with temperature of 200 Kelvin. What would happen to the pressure if the temperature was to be increased to 300 degrees to 300 Kelvin? I'm not asking you to solve for a value, I'm asking you to give me an idea of what would happen. B for this question states, how would you account for this change in pressure? Impression given in terms of the kinetic theory. So this is in terms of the kinetic theory. In other words, tell me why you give me this answer, but explain to me using the kinetic theory, and that we should know by now. Right? So let's start with that. So since it's a special container, what you're going to do is as follows. It did not ask you for any calculation, so you're going to put by first of all stating a reason. It says what will happen, so you're going to say now here, because since we're looking for the pressure, we're going to say according, okay, and we need to put y, according to the pressure law, the combined laws of gases also if you want to, that states keeping the volume, and listen why, the volume constant, because we are keeping the volume constant. Remember, it's sealed, closed, constant, of a fixed mass of gas, of a fixed mass of gas which is heated and not allowed to expand, because you need to state all of this in your answer. State all the facts based on what you were given. Okay, not allowed to expand will then have the gas molecules, and this I want to hear molecules, not just air, hitting hitting the walls of the container with higher speeds. Because remember, why higher speeds right now? Hence the pressure of the gas will increase. Well stated at CXC level. Let's see why. It's a special container which is well sealed or fixed volume, contains a gas with temperature of 200 Kelvin. What would happen to the pressure if the temperature was to be increased? So in your answer, you are to tell me everything that you've been given and also tell me what would then happen. So if possible, you refer a law why you are setting it also. So I put according to a pressure law that states keeping the volume constant of a fixed mass of gas. And how do we know we are keeping it constant? Because it is well sealed, which is heated and not allowed to expand. Because it's sealed and it's fixed, it does not allow it to expand. Contains a gas with temperature. Alright, so we put here constant over a fixed mass of gas, which is heated and not allowed to expand. We'll then have the gas molecules hitting the walls of the container, which is a sealed container, with higher speeds. Hence, the pressure of the gas will increase. So that's the way I want to see the answer stated. Okay, so let's continue with the second part. Now, this is the way I want to see the answer well stated. One will be the vocabulary that you use, 1 point for it, and 1 point for the concept of the pressure law, because you just explained it and why it then happened. The next one says, how would you account for this change in pressure in terms of the kinetic theory? So there's a change in pressure based on the second part of the question. So the way you're going to answer this one here is as follows. These particles, okay, because you want to mention what, how, or why, these particles are always moving. We know that for a fact, and it is this movement which is true, and I'll explain to you why. This movement that helps decide or decides decide what state of matter exists. Let's see what does this mean. These particles are always moving, and it is this movement that helps decide what state of matter it is. Remember, matter exists in three states: solid, liquid, and gas. We know that the faster molecules move, they start to separate from each other, then going from solid to liquid, then to gas. So here you're just explaining that information with this. Particles are always moving, they're constantly vibrating, which is true. And it is this movement, because if they start to move too much, then they will change state of matter. Okay? Now, if temperature increases, then motion of particles increase. If temperature decreases, then motion of particles decrease. So you just explain to it what happens with the particles. Okay, now here comes the last point there. At the same time, so after you don't explain that, at the same temperature, sorry about that, at the same temperature, the heavier particles, which we know particles move slower than the lighter particles. So we just explained the answer. Well said, CXC level. These particles are always moving, and it is this movement that helps decide which state of matter exists, which is true. If the temperature increases, the motion of the particles increase. If the temperature decreases, then the motion of the particles decrease likewise. At the same temperature, as here now, all this combined now, the heavier particles will move slower than the lighter particles. That's the way you're going to answer that kind of question for you to get your 2 points. Okay, so we will go with the next problem now. Here we have, in an experiment, 400 centimeter cubes of gas X. We are not interested in what gas it is. It's just simply a gas was collected. The temperature of the lab was 30 degrees Celsius, or in other words, that was room temperature, and atmospheric pressure at 160 millimeters of mercury. Calculate the volume of gas at standard temperature and pressure. Standard temperature is 0 degrees Celsius, which is 273 Kelvin, and standard atmospheric pressure is 760 millimeters of mercury. So the way you're going to answer this is, first of all, state what you've been given. We know volume 1 is equals to 400 centimeter cube, because in the experiment this is the gas. Okay, 400 centimeter cube of gas. We know that temperature 1 is 30 degrees Celsius. We know that pressure 1 is 160 millimeters cube of mercury. Okay, we now know that volume 2. Now calculate the volume. Well, we don't know that, so we can, that's the one that we will be looking for. But we have temperature 2. It says calculate the volume at standard temperature and pressure. So standard temperature and pressure, despite they didn't give you a direct value, standard temperature is this one here, which is 0 degrees Celsius or 270 Kelvin. I would take the 270 Kelvin one time because the Celsius will need to be converted anyway. All right, and then we have pressure 2 now is what, 760 millimeters of mercury. So we have that. So we need volume 2 now. So we take our equation, we put P1 V1 over temperature 1 is equals P2 V2 over temperature 2. We want volume 2. Applying algebra, we get that volume 2 is equals P1 V1 temperature 2 over T1 P2. Okay, so we do that. Now substitute into the equation, and we end up with 160 times 400. Not necessary to put in the units to avoid confusion. And the 30 degrees Celsius, we need to convert that. Sorry, my mistake here. So 30 plus 273, that gives us 303 Kelvin. So we put here now 273 for this one here over temperature 1, which was 303, times the pressure 760, and we work that out, and we end up with 75.872,850,443 centimeter cube. But notice in your values here, okay, everyone is working with whole numbers, so you could go one decimal point to be much more accurate, and you end up with 75.9 centimeter cube, and that's your solution. You get your full marks for this question. So this is the way you're going to need to solve this type of problems. Be very organized. State the facts, state the equation, substitution, evaluate, and state your final answer. Key points there: state the facts, that's point 1; state the equation, point 2; substitution, evaluate, and correct units. 5 points you get there for that question there. Okay.